Here's a problem from Chapter 10. The data below shows the height in inches and the pulse rates in beats per minute of a random sample of women. And we have data here with the heights and the pulse rates. And the heights labeled X, the pulse rates are labeled Y. And so we want to use these as a test for correlation and regression. First thing we want to do is to find the correlation coefficient, and for us to do that quickly we can use our calculators. So in our calculators we press Stat and Edit, and then preferably in List 1 and List 2 you can type in all the data. So I had already done that, so we can take a quick scan at the data to make sure that we have the right data inputted. 3, 4, 5, 6, 7, 8, 9, 10. So I should have 10 pairs of data here. If I go up to the last pair of data, I see the number 10 and the L2 or L1 parentheses 10. So now I have 10 pieces of data. Okay, now we will go into the Stat button again. And this time we're going to go to Test, and then we're going to select linreg t-test. In our linreg t-test, we will put L1 for our X list, and to get L1 there in case you don't have L1, press second function and the number 1. Oops, let's try that again. Second function and the number 1. And then you get L2. And now whenever we're doing a correlation, we will always select the not equals to option. This would be good to have your regression equation stored into Y1. If you don't have that stored into Y1, for example, if you have nothing there, you're going to go to vars, yvars, function, and Y1. And so that's how you get Y1 there. Alright, let's do a calculate. And we have a lot of pieces of information here. We have all the way at the bottom, if you scroll down, we have your R. So R is our correlation coefficient. So let's make a note of that. R is equal to a negative 0.062758. Now usually they want this up to 3 decimal places. So we are actually doing a test for correlation, so we need a hypothesis, a null and alternative hypothesis. And what's nice and easy textbook about this is that the null and alternative hypothesis for correlation is always going to be the same. The null hypothesis is to say that your correlation coefficient is equal to 0. That is to signify no correlation, and the alternative hypothesis is rho is not equal to 0. And so this rho not equal to 0 implies correlation. So we found our R and we have our critical value. So let's take a look at our table. This is the table, the Pearson table that we have. And for the Pearson table, we want to look at n, and we want to look at the number of elements we have. So in our example, we have 10. And without any indication of what your alpha should be, we'll assume 0.05. So our correlation critical values are 0.632. So that means between -1 and 1, we have a negative 0.632 and a positive 0.632. And our correlation coefficient, correlation coefficient is negative, and it's close to 0. So if you remember anything in here, we fail to reject. We fail to reject the no correlation statement. And everything out here we reject. So we are in this spot over here where we fail to reject the null hypothesis. So our conclusion, there is no correlation. And we should finish the statement based on the problem that was given. There was no correlation between the heights and pulse rates of women. Okay. Another way we could have gathered that information, let's throw in an addendum in here, is if you go up and down, well, the first piece of information they give is a T, and the second piece of information is a P. So the P value in this case is 0.863. And if you remember in your hypothesis test with a P value that's bigger than alpha, assumed to be 0.05 in this case, we fail to reject the null hypothesis. And this is another way to get the same conclusion, but without having to rely on the Pearson correlation coefficients like we did earlier. So another piece of extra information in this case, because there is no correlation, this information is not important or should not be relevant or should not be used. But in any case, the regression line is going to be given by this equation, and we usually denote the regression line by y hat. And so you can get that information from your regression t-test. The y hat is supposed to be equal to a plus bx, where a is 83.089 and then your b is a negative number, negative 0.1939, or let's call that 194 times x. So, like I said, because there is no correlation, this piece of information is not going to be important for us. If there was correlation, then we can do a lot more things with this line, like make predictions and things like that. Okay, so that's it for this recording, and I hope this helps.